You know, as you look in chemistry, there are many aspects of chemistry where it's important to study. And you look at the atmosphere, and one of the major components of atmosphere is nitrogen gas. Well, nitrogen gas can exist in many other states. And so we're going to look at some activities involving nitrogen gas in the liquid state. So what we're going to do is get some liquid nitrogen. Now, liquid nitrogen is a substance that is approximately 190 some degrees below 0 Celsius. We have it inside a Dewar flask, a specially prepared flask that has a thermos lining that will keep it cool for a while. And so what we're going to do is pour some liquid nitrogen into this little plastic cup. Now we're going to pour it in and just keep pouring in, and we want to get the cup cold, colder, colder. I think that's good enough.
You're a cool teacher, Mr. Hepburn.
Oh, thank you. So that's by itself could offer a lot of demonstrations. But what we're going to do is we're going to reduce the pressure by using a vacuum pump. We're putting this bell jar on top, and what we're going to do is turn on the vacuum pump, and what that's going to do is reduce the pressure. And so if we could have the camera just watching what's happening over here. Of course, with liquid nitrogen having a boiling point so low, you can see that it's boiling.
What I ask my students to think about is what's leaving, the faster moving particles with the most energy or the slower moving particles? As the fast-moving particles are leaving, it leaves behind some of the slower-moving particles that have a little less average kinetic energy. What we're doing is we're getting down close to that triple point, and
oh, did you see that?
We are now at the triple point of nitrogen.
And what you were seeing is actual solid nitrogen. Now,
and what happened with that?
Well,
I didn't notice what happened.
It did form the solid. Were you able to get the solid? How'd it look? Okay, let's just quickly, while we're letting this go, do you want to go over to the graph and talk about it, Mike?
Go ahead.
Oh, okay. Recognize that liquids have various boiling points. It depends on what particular atmospheric pressure that liquid is at. Water normally boils at 100 degrees Celsius if you're at 1 atmosphere. Now, if it's starting to go again, Mike, let me know.
It is gone, and what we've done is, we are at that equilibrium point where it's really now oscillating back and forth between the solid and the liquid states. And I've actually had this happen where it will actually, you can tell how many oscillations it's gone to, and it does something different each time I do it. It will actually pancake out of there. You'll have a layer, and then a liquid, and a layer, and a liquid, and it will actually start keeping those layers and pushing them up out of the bowl. Eventually, there's your solid nitrogen, and we were right at that triple point. Excuse me, Jeff.
And so, as I was saying, water normally boils at 100 degrees Celsius. That's when you have an atmospheric pressure of 1 atmosphere. What happens if you take water up to Leadville, Colorado, where you're about 10,000 feet? Guess what? At the higher atmosphere, it reaches its boiling point at a lower temperature, and water will boil at 90 degrees Celsius. If you go up to Mount Everest at a much higher altitude, water will boil even much lower, around 70 some degrees Celsius. Well, if we look at this graph, we can see that we have in a phase diagram the solid state, the liquid state, and the vapor state. And at 1 atmosphere, this is the normal boiling point for nitrogen. So we're right here at negative 196 degrees Celsius. But what we were doing with the vacuum pump, we were drawing out some of the air, and so what that was doing is reducing the pressure. And so as we take this portion of the curve on the phase diagram, it would start inching down because now it was establishing a new temperature at that reduced pressure. And ultimately, we get to this point where we have the triple point, where nitrogen can exist as a liquid, a gas, and, as we can see, a solid. So we're going to try it again, Mike.
We'll try this one more time. And if we can get that to stay the solid, and then we'll let it slowly melt, because it gives a nice demonstration of what happens when the pressure is increased.
So that curve is inching downward to that point where you're approximately 0.14 atmospheres. And the temperature, if we could have a thermometer in there, it would read approximately negative 210 degrees Celsius.
I don't like that they're jumping around.
I know. There it goes. And you can start seeing some of the solid forming.
We've cut off the bottom of a plastic solo cup. I would recommend a bluish, some background cereal bowl, like a children's cereal bowl is what I use in my classroom.
And there's the solid.
And now what I want to do is, see if we can get it to stay. I want to slowly let the air back in there. And I'm going to cut the vacuum pump off. Jeff, cut the vacuum pump off, please. And you can see it go back to its melting very, very slowly back to that.
So, a phenomenal demonstration to show, even though nitrogen typically exists as a gas in its normal conditions, you can exist as a liquid in a Dewar flask or, as we saw here, in a solid state. Thank you.